So in question 3 it says, in the figure below, triangle FBC is an isosceles triangle. DE is parallel to AB. So triangle BFC is an isosceles triangle because these two sides are equal. And they say AB is parallel to DE. And touches triangle ABC, it's C. F is a point on AC such that FB is equals to BC. So FB and BC are equal in length. Then they give us these two angles, angle A to be 44 degrees and angle C3 to be 72 degrees. So the question says, calculate, giving reasons, the size of C2. So we need to provide reasons on how we calculate the size of C2, angle C2. So on the sketch, you'll see that angle C2 is this angle here. It becomes possible to find C2 if we can find angle C1. Once we find angle C1, we can use the property of angles on a straight line at up to 180 degrees. So let's see how we can find C1. So you'll notice that we have a pair of parallel lines. DC and AB are parallel, so we can form alternate angles. Here's your Z shape. So what this simply means is that angle A and angle C1 are equal. So we can say angle C1 is 44 degrees, and let's write this down. So we can say angle C1 is equals to angle A, which is equals to 44 degrees, and the reason is alternate angles. This is because AB is parallel to DC. So now we can use the property of angles, adjacent angles on a straight line add up to 180. So we can say angle C1 plus angle C2 plus angle C3 is equals to 180 degrees. And the reason is angles on a straight line. So now we can just substitute. C1 is 44 degrees, C2 is what we're looking for, and C3, 72 degrees, that's given, is equals to 180 degrees. So we can say therefore C2 should be equals to 180 degrees minus 72 degrees minus 44 degrees. And this gives us 64 degrees. So in the second question, we need to find the size of B1 and we need to provide reasons. So we can label C2, angle C2 is 64 degrees on our diagram. And you will recall that triangle FCB is an isosceles triangle because these two sides are equal. So we know for an isosceles triangle, angles opposite equal sides are, or angles across equal sides are equal. So angles across equal sides are equal. So this angle is across this equal side, and this angle is across this equal side. So if this is 64 degrees, it means this should also be 64 degrees. So we can just label that as 64 degrees. And the way you would write this is you would say that angle C2 is equals to angle F2. And the reason is angles across equal sides of a triangle. Or in other words, base angles of an isosceles triangle are equal. So this is all equals to, so that means that F2 should be equals to 64 degrees. So if you consider triangle AFB, you will see that F2 behaves like an exterior angle. And we know the exterior angle of any given triangle is equals to the sum of the interior opposite angles. So in other words, this exterior angle is equals to the sum of these two angles because they are opposite to this exterior angle. So the way we would write this is we would say angle F2 is equals to angle A plus angle B1 to be specific. And the reason is exterior angle of a triangle. So F2 we saw is 64 degrees is equals to A, which is 44 degrees, plus B1, the unknown, what we're looking for. So therefore B1 is equals to 64 degrees minus 44 degrees, which is equals to 20 degrees. So let's move on to the next question. So it says here, in the figure below, ABCD is a parallelogram. So this here, ABCD. So ABCD is a parallelogram with AD being perpendicular to EB, AD perpendicular to EB. So we have our base here and we have our altitude or the perpendicular height. And then they say DC is perpendicular to BF. So DC over here is perpendicular to BF. So once again, we've got a base and we've got an altitude or a perpendicular height. Let me just label it. So AD qualifies to be a base and this qualifies to be the perpendicular height. And DF qualifies also to be a base and BF qualifies to be the perpendicular height. So the question says calculate the area of the parallelogram ABCD. So to calculate the area of this parallelogram, we have to apply the formula. We have to know the formula for calculating the area of a parallelogram. So we can say the area of ABCD, which is the parallelogram, is equals to the base times the perpendicular height. So now let's see what we have here. We have a perpendicular height here, which is 6 centimeters, but we don't have the base. But recall, this is a parallelogram, and we know for parallelograms, pairs of opposite sides are equal. So in other words, if this is 5 centimeters, it means AD should also be 5 centimeters. So let's note that. So this here is 5 centimeters. So now we have the perpendicular height and we have the base. So we can just plug it into the formula. So the base, as we have seen, is length AD times the perpendicular height is EB. So now we can just substitute. The base is 5 centimeters times the altitude is 6 centimeters. This gives us 30 squared centimeters. So the next question says we need to find the length of BF. Let's see where BF is. BF is this perpendicular height here. So we can apply the formula once again, because we can find this base here, from here to here is the same length, because we know opposite sides of a parallelogram are equal in length. So this then becomes 8 centimeters. So we can then say the area of ABCD, which we just found to be 30 squared centimeters, is equals to the base times the perpendicular height, right? So the base in this case is DC times the perpendicular height is BF. So we can just substitute. So the area of ABCD is 30 squared centimeters is equals to DC. DC is 8 times BF. So we can divide throughout by 8. So therefore, this and this cancel. So BF should be equals to 3,75 centimeters. So I'm just going to note it on the sketch. BF is 3,75 centimeters, right? So the last question says we need to calculate the length of DF. So on the sketch, DF is this length. So already we can see we have the full length, DC 8 centimeters. We can find this length by using Pythagoras theorem because we have this and that, and we know this is a right triangle. So if we find this and we have that, it's then possible to find this because we know this length plus this length is equals to the total length. Let's already write that down. DC is equals to DF plus FC. And let's see what we have. We have DC. We have DC to be 8 centimeters. We need to find FC using Pythagoras theorem. Once we have these two, then it's possible to find that distance. So let's use Pythagoras theorem. So the square of the hypotenuse BC squared is equals to the sum of the squares of the other two sides, which is BF squared plus FC squared. If you consider this triangle, this becomes the hypotenuse and these are the other two sides, right? So BC squared is 5 squared and BF squared is 3,75 squared plus FC squared. So 5 squared is 25 and 3,75 squared is 14,06, correct to 2 decimal places, plus FC squared. So therefore FC squared should be equals to 25 minus 14,06. So FC squared is then 10,9375. You just take the square root on both sides. Square root and square cancel. Therefore FC should be equals to, this gives us 3,31 centimeters, correct to 2 decimal places. So now we've got this length here, that is 3,31 centimeters. So we can just note it there, 3,31 centimeters. So we've got this, we've got that. So now let's find what the size of DF is going to be. Let's find this distance here, right? So let's plug what we have into this equation. So DC is 8 is equals to DF, what we're looking for, plus FC FC is 3,31. So therefore DF is equals to 8 minus 3,31, and this gives us 4,69 centimeters, correct to 2 decimal places. So moving on to the next question. Right. So it says in the figure below, ADC, triangle ADC is an isosceles triangle. So triangle ADC is an isosceles triangle with these two sides being equal, is produced to be. So it's produced to be here. AB is joined such that B is 27, angle B is 27 degrees, and AD bisects BAC. This is important. Line AD, yeah, bisects this angle into two equal angles. So let's already just make that note on our diagram, right? And then they say let A2 be equals to X. So let's label A2 as X. So because A2 is X, it means A1 is also X. So the question says calculate giving reasons the size of A1. They want the size of A1 and we need to provide reasons. So if you consider this triangle, we can see that we're working with an isosceles triangle. So we can express these angles here in terms of X. So let's go about finding D1. Why we need to find D1 is because if you consider this triangle, triangle ADB, you can see that D1 behaves as an exterior angle. So this becomes the exterior angle, and we know the exterior angle is equals to the sum of the interior opposite angles. So that's why we need to express D1 in terms of X, because we can relate D1 to this angle and that angle, and eventually we can solve for X. Once we have X, then we can evaluate what A1 is. So we know one property of an isosceles triangle is that angles across equal sides are equal. So this angle is across this equal side, and this angle is across this equal side. So angles across equal sides are equal. So we can say that D1 is equals to C. And the reason is angles across equal sides of a triangle. And because they're equal, I'm just going to label C as D1. So now we can use sum of interior angles of a triangle to express D1 in terms of X. So we can say D1 plus C plus A2 is equals to 180 degrees. And this is because sum of interior angles of triangle. But we saw earlier on that D1 and C are the same. So I'm going to write this equation as D1 plus D1, because D1 and C are equal. Angle D1 and angle C are equal, plus A2, which is X, is equals to 180 degrees. So 2D1 is equals to 180 degrees minus X. So you can divide throughout by 2. So these two cancel. So D1 then becomes 180 degrees over 2 minus X over 2, which is equals to 90 degrees minus x over 2. So now we have d1 to be 90 degrees minus x over 2. So now we can use the property of, if you consider this triangle ADB, you can see that this D1 behaves like an exterior angle to these two interior opposite angles. So we can say that angle D1 is equals to angle B plus angle A1, and this is because exterior angle of triangle, right? So D1 we've seen is 90 degrees minus x over 2, angle B is 27 degrees, and angle A1 is x. So we can group like terms. So this is 90 degrees minus 27 degrees is equals to x plus x over 2. So this is 63 degrees is equals to x plus x over 2. So we can multiply throughout by 2. Why we multiply throughout by 2 is because we want to eliminate this 2. So this is 2 times that, and this times 2. So 2 times 63 is 126 degrees is equals to 2x plus x. So 126 degrees is equals to 3x. So now we can divide throughout by 3. So 3 and 3 cancel, and 126 divided by 3 is 42 degrees. So therefore x should be equals to 42 degrees. So the next question says we need to find the size of C giving reasons. We saw earlier on that D1 is equals to C. So we can say D1 is equals to C. The reason is angles across equal sides of a triangle. Angles across equal sides of a triangle. But we found D1 to be 90 minus x over 2 earlier on here. So I can just substitute that. So it's 90 degrees minus x over 2 is equals to C. And we found the value of x to be 42 degrees. So we can substitute that. So therefore C should be equals to, angle C should be equals to 90 degrees minus 42 degrees over 2, which is equals to 69 degrees.